This is a treadle grinder. I recently found out the internet thinks treadle grinders are cool. And I think that you thinking they are cool is really cool.
Holy shit! Look at this!
The internet likes my treadle video. Huh. You know, it'd be fun if people make their own, right? Woo! Yeah, we can all get apocalypse ready. First, we need some scrap. This scrap was cut and a center hole was drilled to hold the flywheel. I got the flywheel, some bearings, and a pulley from this old exercise bike. The flywheel's bushings needed widened center holes. I used a step bit to do this part. Just like that, the flywheel was mounted. But now I need the piece that comes up through here. I hoard scrap, so I just dug around until I found some okay tube steel. But I'll let past me explain the logic I was using here. This guy is a nice sturdy chassis, and that's gonna go through here. I want this to be slightly adjustable for the tension, so I'm gonna have to do a tapped hole in this piece that came from that pile, and then on here is gonna have a through hole. So maybe, just maybe, adjusting a bolt here is going to tighten the belt. I'm also going to tap 2 holes or 1 hole on the back here. I'm using holes that are already in this because, yeah. But I want to show how I tap. Use the I told you to move wrench and tell it to move.
Hey, that's cheating!
Perfectly tapped hole. Now I'm going to repeat the same thing with this guy, only it's a little bit more finicky because he's tiny as hell. Well, we won't judge him, will we? Tapped the hole so that one of these can slot in, because I'm going to need a tracking wheel up here. Dug this out of my scrap pile, and I've been playing with this, sort of judging where it needs to go. And I figure this piece is the right size, and it's going to be able to come in and sort of sit there on the side of the part that slots in. Oop. So I just need to widen that hole so that it is that size. I use a step bit. I already made some custom washers, just with hole saws, and that's gonna help the bearings. Yeah. There we go. And I'm going to use this hole because I need to be able to adjust. This, in all likelihood, this one is going to be under. That's going to connect to the one that goes in there. That might be the one that goes in there. It went in so easy. You know what? He belongs. He belongs. Don't worry if this looks complicated. I'll have the measurements and CAD files for this beast can be bought by contacting me. Just follow what I'm doing now on screen. But back to the build. Plan set with the individual parts and measurements. Got away with myself a little bit. So, I need to be able to position this under the pulley, alright? So this tube still telescopes over this. I can loosen that and adjust that and position the pulley as needed that way. And then with this pivot point, I can control the pivot of this pulley on that axis, and then because it's hooked through here, I can control that axis. So I've got up, down, that way, that way, that way, that way.
For Frodo.
I also have to drill through holes and tap the bottom holes. The base that you see here came from another build. I don't know if that's cheating for a DIY project. I've decided it isn't, but you know, you can decide otherwise. And I'm gonna have to bolt or do something in here for the lever, but we're just going step by step, right? Alright, these holes are larger than they need to be. And that means that we can afford a tiny amount of inaccuracy. Alright, so there we go. 12mm. Locking this middle one in place. So now need to figure out exactly where I need this. So I went best of both worlds. Tapped. And then just a through bolt for the top. Now that this is all together, we can draw where this is going. For these bigger holes, I use a step bit to get to the exact thickness, and I'll go through this way with the step bit and then this way and widen the hole to where I need it. Now that connection piece was in place, I could fit it together for the first time. I may not look impressed, but trust me, I was. Now I'll show him in use, see if anything goes wrong.
In the business, we call this foreshadowing.
Woo! Alright, update. So I swapped this to the other side. It's kind of easier to take off this arm to access this.
Well, didn't think it'd be simple, did you?
I suppose I just didn't think.
Couldn't have. Oh, Johnny. Johnny, what's the matter with
With the tracking arm done for now, I turn my attention to the mechanical linkage that drives the whole thing. It was working, but now it needed a Treadle footrest. So this is the mechanism I've gone with. All I need to do now, put a shirt on so you don't all get blinded.
Oh, now you care.
This is going to connect the wheel that's going to hold the belt at the top. Over. I know that is not a quick belt swap, but I like this being secured by both if I'm doing a plan set, because, you know, flywheel can be pretty dangerous. So close to being finished.
That is without a doubt the dumbest thing I've ever heard. You are a f***ing idiot.
Guess I've done a bit since I last updated the camera, but I forget a lot. So we'll start with tracking arm. And you just change the tension by pulling it up. So it has tilt between these two plates and this tilt between that. And then I cut these short, so I didn't like how far they came out. And then I attached this. This is the platen, and that is adjustable this way, forward and back. We've got a work rest. Drilled a hole through here on some angle alley, and then just tapped him up into there. And then I can adjust this anywhere I kind of need to by adjusting that bolt and that bolt. So I can get it from here to here. Here is the problem. This 3-piece chassis bends way too much. I like something being adjustable, but I think it's just asking for an accident to happen. So, this guy is going to replace that. I need to make a bracket for that. Don't mind the dogs. Getting my scrap steel from my scrap steel pile, and I'm going to cut out these 2 brackets. For the purpose of the DIY people out there, I cleaned it up with the angle grinder real quickly, and you know, good finish. I drilled the first hole with these plates separate, and then bolted it together and drilled the second hole with it sort of templated. Threw a bigger arm on to hold the pulley. I threw tracking on this, and I threw tracking on this. I also upgraded the tracking mechanism. Needed something adjustable, but you know, I like that tracking mechanism. I made this a bit more robust or rigid by adding a second arm and making sure that it pushes on both sides of this wheel. We have got a problem though. Everything is working almost great. Almost. It's hard to see it, but the bearings washer is off center. My solution is going to be cutting off this part of this because I need this bearing holder right here. So I cut this out and packed the inside with some spacers. I had to sacrifice half of the tracking mechanism to mount this, but that's okay. The pulley arm is connected through here, which means that you can let off the tension when you need to. Super handy.
It's a feature, not a bug.
Now it's time to give it another test run to see if it works. After playing with it for a bit, I decided.
I could say there's nothing wrong with it. Right? I really could. I could lie to everyone and say that there's nothing that could be improved. There's one problem though.
There is a simple way to make this part more sturdy. Oh, I like how much I've reduced the risk of losing fingers. Not completely. Oh, I'm not going to try.
You're a dumbass.
Anyway, so this part can be attached to here, right? And then it can have a bolt going through into there, which will hold that tight, and then maybe I put a cover over it as well. This piece of steel, and I can just bolt through there. There's already a hole here. Just need to put a hole there, and then cut some threaded rod and put a hole there. 5th of July is today. Version 1 of version A is done. Solved the problem I was talking about with this rod connected through, and you can see a gap in the steel because I tilt it to get the right tracking and then get this to just finger tight to get rid of the vibration. without losing the tracking. And this is just bolted through. There's nothing holding this in place right now. It's holding in place on the other side, and no bearings either. Alright, just sort of, right size hole. I can adjust the stroke length by adjusting this. If I take it further out, it ends up being higher. If I put it further in, it ends up being lower. Alright, so we need to test it. I've got this piece of pre-hardened saw steel, and this is just a little leather knife. Important to say that word so that it's legal. Alright, and I'm gonna grind him on this. The project feels worth it at this stage. I like knowing I can make sparks fly without electricity, but before long... Another improvement was staring me in the face.
Want to hear the most annoying sound in the world?
That's disgusting.
I have to use this because it stays on better. So I'm going to drill a hole there. This is what that part looks like afterwards. It's not pretty, but it doesn't have to be, as long as it works. Now back to finishing cleaning up the sides of this knife. Alright, so sides are done enough. Done enough. Can't really see it right now. Oh, I love this. Now I'm gonna do the back side with the big wheel and just try to get past that sort of cut mark. But before I did that, I cut down an abrasive belt and swapped it into place. Did this for the OCD people who didn't like the belt overlapping the edge. You know who you are. Though this means my platen is now too wide. But can't win all of the battles. And I feel good enough already. I mean, check out how cool this beast looks. I know it's not perfect, but it's a mighty addition to my workshop. Treadle grinders may have been abandoned by most, but this is my new favourite machine. But as it goes, I wanted to keep going forward with the idea. So after some obligatory use of this freshly cut belt, I swapped to a belt that was glued straight to the flywheel itself, losing the platen, but gaining simplicity and a bit more speed. The next upgrade was a spring to assist with the upstroke. This made the machine move so much more steel than before. Though the price was a more exaggerated swaying effect at the same time. But it's still passing all of its tests, because after I was done shaping the back of this knife, I got through the cutting edge profile and the finger grooves no worries. I even discovered my belt has an automated removal feature. Just in time to swap out the abrasive for grinding in the bevels. I tested two different methods for this. The first was a simple jig ran over the wheel. The second, an arm with a big magnet to hold the metal at the desired angle. After a bit of testing, I decided a smaller magnet provides the best of both worlds. I also finished the bevels in my testing, so now we are up to establishing the cutting edge and then sharpening. The variable speed, if you can call it that, comes in handy for this task. Once this was done, I took off my belt to use the leather as a strop. Let me know in the comments if you think this treadle grinder has proven its worth. But while you're thinking about that, I have a metal cutting attachment to test out. What do we got? Cool looking linkage that does a slicing motion, just cause. made a rail out of this wheel holding pressure down and holding that in between the bearings. A quick release sort of arm so I can change out the tool that's being used. Actually, back to here. This pivots so it goes down, which means that with the weight on the end, the arm will slowly go down with pressure. But in here, I also have a spring plate that I can change the height of, that pushes up, and then I can let off these bolts to let this up further if I need to. Just in case anyone wants to make this, thought I should show the inside. Right. You can adjust the pin up or down. And the pin can go under this or through there. And this just goes up and down. So, you know, we put in right? And then this is at this level. And it pushes up. Right? So you can sort of have the workpiece pushing up as the saw is pushing down. This is pushing up. Yeah. And then just made a clamp at the top. So this attachment was more just mad creative testing. So I'm going to run this now and see if I can cut through this steel. For this attachment to be truly justified, it will need to cut well whilst I'm using the grinder to work on a blade, making it truly multi-purpose. Also, before we dive into this test, I wanted to show off this attachment's tracking mechanism. I'm never sure what people want to build, so I figure I should just show every square inch of the machine in this video. So these two bolts I was gesturing towards apply constant pressure and help keep the linkages from getting twisted. Let's see if something breaks. I like it. That's not ideal. I think the alignment was off, which was pushing the saw left to right. So I messed with that off camera, then tried again, with slightly improved results. Until this started happening. So the problem we're running into is this is twisting, this is tilting, which makes sense, not a sturdy enough work hold. But it doesn't have to be if the alignment is correct. So I did even more messing around off camera, then tried again. And again it was working even better, which is a good sign. You can hear it cutting. You can see it lifting at the end of its backstroke, but it's still not perfect. Might be going wrong. We're going wrong. So this is the problem with one of these machines. A lot of people lost fingers because of it. So that's also why it took so long for me to develop this, because it needed to be safer. Although that almost works better. I don't mind that. So it's slowed down by itself. That didn't go terribly wrong, even though it went wrong. Because I was expecting this to snap if it gets twisted. Try again. So I'm just gonna apply some speed to this. See what happens without that guide in place. Alright, he's up to speed. Now, I'll just put the weight on. you can actually hear how much the extra weight helps the cutting. Now that the saw was working with no problems, it was time to let off the work rest springs completely, significantly increasing the pressure between the saw and the metal. If the springs are too strong, then this will turn into a destruction test. So let's fire him up.
Oh, big cuts. Big cuts. It's passing so far. Holy sh... That's decent. That'll get through him. The next test. Can I grind a piece of steel whilst it's going? Because then it's like I'm not even wasting the time.
I've got this arm on a 3-axis, well, 4-axis, maybe more, I don't know, but good old-fashioned Fission's Knives file guide. This is the magnet arm, the hole drilled through, and the idea is, alright, so I see this attachment as being successful if I can still use this for its intended operation whilst, you know? Oh, he looks wicked. Definitely looks like it's made by Fission's Knives. In a strictly technical sense though, because this attachment is incredibly slow at cutting. But I can grind knives whilst it's doing its thing, which was the goal.
Getting there. Getting there.
So now let's check our results. So I should be able to just do that. Yeah, that worked. Now is everything holding together? Yeah, everything's still straight.
Here's the cut so far. So, I mean, look. In an apocalypse scenario, this can cut carbon steel. You know, a nice straight cut line. You know, or, I don't know, maybe a groove on a knife or something like that. But, holy that is not quick. It's 7 minutes.
But I can have it running whilst I'm grinding. That worked. It's an interesting use case. It'll do wood way quicker, but you don't really need to automate wood cutting. I think as a test, I'm going to leave it there as an attachment for now.
We were doomed from the start. Nothing remains now but for the captain to go down with the ship.
Because I have an angle grinder. Oh, this is as handy as my belt grinder. That is not as handy as just doing it by hand. But I've got 2 drill presses in here. And I am gonna try to rig it up to the drill press and see if that works. Yeah, well, that'll be interesting. Manual drill press. Alright, so I made a decision. This is coming off, but I'm leaving the mechanism. So that's working great. Using it as a metal saw might be dumb. So, next goal will be a wooden, nice way to mount the file. And then I think that's an appropriate sort of attachment. I could use this to make a file, maybe. Something to that. But I think that concludes this video. Machine is functional. The treadle grinder is working, and I'm just getting onto attachments now. I prefer it this way, but I still have the arm to set it up the other way, and that wheel that's up here when it's set up with the arm is going really quick. So I'm gonna play with the wheel, you know, so it's very, very relevant being able to hook that up. But this option for me works the best for grinding knives, just day to day. This arm is pretty much perfected. This is not innovation, by the way. This is me copying very, very old Japanese people, kind of, and then putting my own spin on it. Yeah. Oh god, that's cool. And that is the video. I hope you enjoyed.